The role of mat foundations in skyscraper stability. When it comes to constructing skyscrapers that touch the clouds, stability starts far below the surface. One of the most essential elements of that stability is the mat foundation. Also known as raft foundations, these massive slabs of concrete spread the load of a structure over a large area of soil. In the world of skyscraper construction, where enormous weights need to be safely transferred to the ground, mat foundations play a critical role in ensuring that buildings stand strong for decades, if not centuries. Why skyscrapers need special foundations? Skyscrapers aren't just tall, they're incredibly heavy. With structural steel, reinforced concrete, and floor after floor of systems and finishes, the loads can reach hundreds of thousands of tons. These loads must be transmitted into the ground safely and evenly. Traditional isolated footings would cause uneven settlement or even failure in soft or variable soils. That's where mat foundations step in. By acting as one continuous slab beneath a large portion or even the entirety of the structure, they reduce pressure on any one part of the ground and help distribute the weight uniformly. What is a mat foundation? A mat foundation is a thick, reinforced concrete slab that sits beneath the entire footprint of a structure or a significant section of it. Unlike spread footings, which are only placed beneath columns, mat foundations connect all the loads together and spread them across a wide area. In skyscrapers, mats often range from 2 to 6 meters thick and are heavily reinforced with multiple layers of steel rebar. They function both structurally and geotechnically, offering load distribution, settlement control, and resistance against differential movement. When are mat foundations used? Mat foundations are typically used when the bearing capacity of the soil is low, but the building loads are high. They are especially valuable in high-rise construction on soft clays, loose sands, or reclaimed land, where deep foundations like piles may not be economical or where uniform settlement is a key concern. They are also chosen when the columns are closely spaced and individual footings would overlap. In some cases, mat foundations are combined with piles to create a piled raft foundation system, maximizing stability and minimizing differential settlement in complex soil profiles. Design considerations for mat foundations. Designing a mat foundation for a skyscraper involves understanding both the soil behavior and the structural demands. Engineers begin by conducting detailed geotechnical investigations to identify the soil's strength, compressibility, and settlement characteristics. Then, using software and finite element models, they simulate how the mat will behave under different load combinations, including dead loads, live loads, wind, and seismic forces. Reinforcement is carefully designed to resist bending moments, shear forces, and punching shear around heavy columns. Drainage and waterproofing systems are also incorporated to manage groundwater and protect the foundation long-term. Construction challenges and techniques. Building a mat foundation is no small task. Because of their thickness and size, they often require massive concrete pours, sometimes continuous for 24 hours or more. Temperature control is critical during curing to avoid thermal cracking. Engineers use techniques like cooling pipes, staged pouring, and thermal monitoring sensors to manage hydration heat. Reinforcement cages must be meticulously tied and placed to exact tolerances, especially under skyscraper cores, where loads are highest. Any construction error in this phase could affect the entire building's stability, so quality control is rigorous. Performance in real-life skyscrapers. Many of the world's tallest buildings rely on mat foundations for their success. The Petronas Towers in Malaysia, Taipei 101 in Taiwan, and the Shanghai Tower in China all use mat foundations to stabilize their incredible height. Even the Burj Khalifa, which uses a combination of a mat and deep piles, starts with a massive 3.7-meter thick mat to distribute loads before passing them to the piles. These foundations have performed exceptionally well, with monitored settlements staying within predicted ranges and no signs of structural distress even years after construction. Why mat foundations will remain crucial. As cities continue to grow vertically, the need for strong and efficient foundation systems will only become more pressing. Mat foundations offer a simple yet powerful solution for skyscraper stability. Their ability to spread loads, resist uneven settlement, and perform under a variety of soil conditions makes them a go-to choice for engineers around the world. Combined with modern materials, simulation tools, and construction techniques, matte foundations provide the bedrock, literally and figuratively, for the towers of the future. Thanks for exploring the deep foundation science behind our tallest structures here on Blueprint to Reality. If you found this fascinating, make sure to like and subscribe for more insights into the unseen engineering marvels that keep our world standing strong. Stay grounded, stay curious.